So this talk is about deploying Cassandra in multi-cloud, and we're on a journey. So this is not a representation that we have all the answers about the one right way to do this, but we have some ideas about the best way to do this. We've started down the road of taking a reference application that we have, KillrVideo, and deploying it in multi-cloud. And so this is kind of one of the waypoints along the way. Is this talk is sort of like a snapshot of a point in time of where we are at in taking our app and deploying it multi-cloud. So I have Adrian here from our developer advocate team, along with myself. So Adrian's gonna say hello. Adrian and I are developer advocates at DataStax, and this is a project that our team has taken on. So I want to shout out to him because he's also played a big part in this project. So let's talk about what is multi-cloud, first of all. So let's say I got my Azure console here. I'm set up to start deploying some infrastructure, and maybe I have a workload in Cassandra or in Azure, and then now I got my AWS, and so now I'm deploying some other stuff in AWS. And the moment that I have two cloud consoles, does that make me multi-cloud? No. So this is our Patrick meme, which we like to bring out every once in a while. I don't know if it's only funny for internal purposes, but I'm going to go out on a limb here and say that it's just funny. So no, what really matters here is that we want to be actually having meaningful interaction between clouds. So this is where I'm getting at with these hybrid cloud versus multi-cloud definitions. We threw these out here on Twitter just to see if we could get anybody to argue with us, and we didn't really. I was sort of disappointed. But hybrid cloud, most people think of that as being kind of like on-prem, and then I'm gradually moving some of my workload into the cloud, and I have interconnections between those two. Okay, so on-prem plus one cloud provider, maybe that's hybrid cloud. Multi-cloud, we're thinking of as having at least two public clouds that we're in. And I'm not saying that like one department has some random workload and some other department has some other workload. I'm talking about actually having a meaningful traversal of data between these two. That's what I'm most concerned about when I'm thinking about Cassandra from a multi-cloud perspective. So why are people doing this? Reason, these are my opinions on the relative merit or hype versus not hype of some of these reasons. So what I think is pretty legit is people who are trying to have data center locality. They're trying to move data as close to their customers as possible. Depending on where in the world that is, the closest data provider may or may not be nearby. So this is probably especially true in places other than US and Europe and parts of Southeast Asia, right? So there's other parts of the world where you may not have so much selectivity in terms of your nearest data center. Next is people wanting to actually take advantage of different cloud providers for the different services that they provide. So one example I've heard pretty frequently is people really liking capabilities that Google provides from AI and machine learning perspective and wanting to take advantage of those. Maybe they have a lot of data that happens to be accessible in S3 buckets, and they're trying to get that over from AWS into GCP in order to be able to do some analytics, big kind of number crunching stuff on it. So that's an example of some cloud provider has a specific service that I really want to use. And so now I'm thinking multi-cloud because I want to take advantage of the best of breed from a different catalog of available services. Okay, that's a pretty legit reason. One of the reasons that I hear that I'm not quite as sure about is this idea of kind of competition between cloud providers, and specifically with relationship to cost. Like I'm going to be shopping around, and I need portability because somebody may have a lower price on infrastructure, and I can get my cycles for cheaper, my compute for cheaper if I move my workload. That might be the case. I don't know that that's a major driver in itself of multi-cloud, but what I do hear is the corollary to that I do hear is kind of the idea that for some industries, some people are worried about a provider like Amazon kind of moving into their space and moving into their field. So they're using this multi-cloud as a hedge. Like I'm a healthcare company and I hear that Amazon may be doing healthcare. Maybe I want to hedge and not have all my workload in AWS. I do hear quite a bit of that. So one of the things that I think is an interesting consideration when you're talking about a multi-cloud solution is, are you just trying to duplicate the same workload in multiple clouds, or are you actually moving different parts or different capabilities or different portions of similar workloads, like your live operational workloads? Are you dividing that up across multiple clouds, or are you just trying to run this multiple copies of the same thing in different places for resiliency? We'll kind of get back to that and dive into it more. This is kind of a broad survey or a little bit of a roadmap for the rest of the presentation. When you get into developing a multi-cloud solution, you're going to run into a number of things. First of all, there's some fairly simplistic things to get over that are kind of surface level considerations, but there is a little bit of a mental hurdle to get over, in that everyone names everything differently. So there's a certain amount of complexity that you run into in that impedance mismatch between, it's I don't know what to call it. It's a VPC here versus a different, someone else has a different name for that type of networking environment, for example. Speaking of networking, we have considerations about if I am having multiple points of entry in different of these public clouds, how am I balancing the load between them? How am I using name services to route the traffic and make sure that I end up at the right location? There's also considerations about the latency between the public clouds. So this has to do with not only the security of the connection that I have between those clouds, but also what is the latency between them. When I get into the application tier, how am I going to scale that? Especially when am I scaling each one of those clouds independently of each other? Where do I need to have caches? Do I have multiple caches? Do I have them in each data center or in each of these public clouds? When I get down to the database tier, now we're starting to think about solutions regarding where am I allowed to keep data? What are the regulatory and legal controls about where I can store data in each one of these public cloud providers? And then finally, security is kind of one of those capstone things that cuts across all of the layers. So do I need some kind of federated identity management solution that's across all of my cloud providers? How am I going to protect my boundaries? I not only have boundaries to the public internet for public-facing things, but then those private boundaries between different data centers and between different cloud providers. Where am I going to need to use encryption? Where do I have compliance and auditing kind of requirements? So there's a broad landscape of stuff, and I'm not saying that this presentation is going to give you the answers for all of those. I'm just trying to say, like, here's the list that we came up with of all the, maybe not all, but at least the starter list of questions that we should all be asking. So we took a certain subset of these for our efforts to port KillrVideo. So this is, this is kind of like our advertisement for, we think that the data tier is possibly, with Cassandra and DataStax Enterprise, that might be actually one of the easier parts of the problem. That's been our experience as we worked toward this effort on KillrVideo, has been the configuration of, the snitch and the replication strategies and et cetera. That's tends to be a lot easier than actually getting all the networking parts right. So we'll dig into that a little bit more, but that's just sort of, I'm throwing out a thesis at you up front here. So if you haven't heard of KillrVideo before, this is a reference application that our developer advocate team maintains at DataStax. The thing that I can say that I think it's great because it's my team's responsibility, but even before I was a part of the team, I thought that it was a really great resource for learning how to develop with Apache Cassandra, with DataStax Enterprise. It makes full use of the drivers that DataStax provides. We have, it basically, actually, I'll show you the architecture diagram, and it'll make more sense as I explain it. If you didn't catch, I can always give you the slides later on. All the source is freely available on GitHub. And then you can go to KillrVideo.com if you want to see a live running instance that we have running in AWS. Although David Gilardi told me not to send people there because he said it was flaky. And we were at Strata all week, et cetera, et cetera. I guess we're not ops experts.
Is it flaky?
Well, he said that there's a whole thing about the scalability of the Gremlin query for the recommendation engine, that it kind of tends to slow down. Yeah. It was great. It was a great moment where we put up on a slide, like, here's a traversal that we're using for a recommendation engine, and Jonathan Ellis was like, I don't think that's going to scale. And I was like, how do you even read the Gremlin that fast? That's another talk. So architecturally, we have a web application that we've written in Node.js. That's actually the screenshot that you saw there. That's obviously our Node.js front end. Then we have a service tier, and we have implementations of those services in Java and in Node and in C#. And I would love it if we could get a Python one, so that's on the roadmap. We have like a common interface description. We've chosen to use gRPC. So we have gRPC interfaces that we've written, and then bindings that we've generated for each of those implementation languages. And the great thing is you can go to the Java implementation, and we're using the Java driver. Same thing for the C# driver, et cetera. So there's two main ways that we deploy this. One of them is you just download the code, or you clone the project, get the Docker images. We have like some Docker Compose files. So you clone the repo, run a Docker Compose. That'll grab all the images that you need. It'll create an environment for you, and you're running the whole thing in Docker on your desktop. We've also deployed it into AWS, and that's using clusters that are provided and managed by our DataStax Managed Cloud team. So kind of have it two ways, the developer deployment, and then kind of our, I don't know what you would call enterprise or real deployment. This is just another way of kind of visualizing that same architecture. The only additional detail that I want to call out to you on this one, because I know that it gets a little busy and small, is really just that we have a generator that we use that basically just like, KillrVideo is like a video sharing application, and basically we're not managing all of those large binary files. People ask me that sometimes, like, where do you store all the videos? Well, it's really just, it is a reference application, and it's a sample, so the videos are actually stored in YouTube. We're basically kind of like a catalog of sitting on top of what's in YouTube already. So we have a generator that basically like pulls videos from YouTube based on tags or keywords, and then inserts them on a periodic basis. And so we have a continually growing data set. We're auto-generating users who are liking the videos that are generated, and they're rating the videos. And so we have a continually growing data set, basically. And then we have a recommendation engine that we've implemented with DataStax Enterprise Graph that will calculate based on, let me see if I can describe the algorithm in one sentence. Based on movies that you like, that groups you with other users who like similar movies. So movies that those other users who are like you, similar users, there we go. Movies liked by users whose tastes are similar to your own, right? It's a similarity matching kind of thing. We're also using etcd as a service registry, and we'll talk about some changes on our roadmap for that at some point. So for this deployment that we have on Amazon, it's actually in 3 different availability zones. 2 of them are US West located availability zones. Actually, no, I'm sorry. Oh, okay, this is an old diagram. The 3 US, in the US West region in 3 availability zones. Okay, so we won't dwell on that or dig into that too much. It's another eye chart. So we are using our DataStax Managed Cloud product. So our cluster that we're running KillrVideo on for our instance in AWS is not managed by the Advocate team. It's managed by our DataStax Managed Cloud team. So we're kind of beta users of this service ourselves. And the point here is that there's kind of a spectrum of how involved you may or may not want to be in the management of your database tier. So you can definitely deploy all the images, deploy all of your Cassandra nodes and manage them yourself across multiple clouds. What we had chosen to do for at least part of our implementation, or one of our implementations, is just use the managed cloud service. Now, the managed cloud service is not yet multi-cloud. It's running, as of right now, it's available in AWS and it's available in Azure. So when we went to go and do this capability and build it up on our own, we were no longer able to use the DataStax managed cloud. We're on our own, we're managing our own cluster at this point. So here's the desired end state. Project goal of take KillrVideo multi-cloud would be that we want to deploy in AWS, Azure, GCP. We're just going to have a single data center per public cloud, keep it simple. We want to have our full stack of services available in each DC. So I'm not isolating workloads. I'm not having an analytics workload one place and an operational workload some other place. This is just like straight up duplication of the full KillrVideo stack in each cloud. So we're going to have the same data availability. I'm not trying to solve a GDPR problem yet. That's not the purpose of this demo. We're trying to have, we'd like to have a secure network between the different clouds. We are not trying to have interactions between the web and application tiers per data center. So in other words, I'm not taking services on AWS and trying to talk to my DataStax cluster in AWS and then fail over to have the services talk to the nodes in Azure. We haven't implemented any sort of like retry strategy across clouds like that. So we're just trying to go full vertical slice in each data center, and our point of intersection is the DSE cluster, sharing all the data across that. So that's the goal of this particular project. What you see here is this is a live view of a cluster that's been created for this deployment. It's not running right now, like we literally spun it up to take this photo because it's automated, right? Spun it up so we could take the picture and then spun it back down. Because apparently people don't think, when they're actually doing real work, they don't think of taking screenshots, funny enough. I don't know why that is. So what I'm showing you here is that we have live AWS, Azure, and GCP, 5 nodes per data center here. And the way that we chose to do this is we actually, we do have write scale such that we can kind of script things out in terms of create the infrastructure per data center. We're not quite to the point yet of having Terraform stuff built up for provisioning everything, but that's definitely on the roadmap. So basically this cluster was created through manual instantiation of infrastructure, and then we used DataStax Ops Center. We used the Lifecycle Manager. So that was the easy part. The Lifecycle Manager you can see it here, the log just kind of blowing through, creating all of those nodes per data center, those 5 nodes per data center. And there's more to it, obviously, like AWS and GCP got created, and then the Azure ones are on the log below. So all of this spun up, I think it was about 15 minutes, if I'm right, like the whole start to finish. Okay, so the database tier, that was the easiest part. But I'm just going to kind of walk down the stack here, starting with the application tier. So building a multi-cloud app, here are the things that we were thinking of that you want to be thinking about. And then I'm just going to kind of go through and here's how far we've actually gotten and what we've implemented and kind of what's left to go. Okay, so you want to be thinking about the deployment of your application tier. How are you going to scale it up and down? Are you going to be using something like Kubernetes to help scale the services or even more monolithic things, I guess, that you have in that tier? So that orchestration and scheduling. What are you going to do about service discovery and routing such that you don't have to go in and continually stitch everything together? Which tech are you going to pick for that? And then are you going to need, I recommend that you do need something like a distributed tracing solution so that you can really begin to keep track of what's going on. And the holy grail for me, which is achievable, although we haven't totally gotten there yet, is to have that distributed tracing where you can track where something comes in at your web tier and watch what happens all the way down through the service tier. And into the DSE cluster. So that is part of that eventual goal end state for us. So as I mentioned kind of on those previous pictures, we're at the point where we've manually created the compute and then used Lifecycle Manager to provision instances. So we've got that. And yeah, that's reproducible, but not obviously the desired end state. And our current solution uses etcd for discovery. What I'm interested in doing is actually, we currently, when we deploy our services, they're actually all running in one JVM for the Java implementation. We're looking to break that up and then actually, because the services, there are services that have interactions between them. So want to make some improvements there to the event layer of the application, and then make sure that we're using service mesh technology, leaning pretty strongly toward Istio, getting that in place, which makes use of Envoy as kind of the sidecar that helps out with that, hooking everything together. So we're looking to implant that and then begin using Terraform for kind of the scripting and speccing out what needs to be deployed, and definitely using Kubernetes at the application tier. What we're kind of maybe not super decided on yet is the use of Kubernetes at the database tier specifically. So we're just at the point of starting to look at this Kubernetes operator that Ben Brahmed from InstaCluster has been talking about, and I don't know if he already did his talk or if that's coming up later on. That happened previous to this, right? So go and check out. We're looking at that and what it looks like for that to be kind of ported or extended for DataStax Enterprise. So this is kind of one of the things that's on our roadmap. But just kind of taking big picture, the kinds of things that you need to be thinking about at the database tier. I've made an assumption. The bullets on this slide assume that we're talking about a Cassandra-based solution. I'm not talking about like in general in the wide world of database technology. I'm thinking specifically if you're talking about a Cassandra or DataStax Enterprise-based solution, what do you need to think about? So how are you going to configure your cluster topology? That's one thing. What are you going to do to set your key space replication strategies? And then what are some of the security best practices? And the security best practices are really not a lot different than you would have for any cluster that you were trying to secure in general. So what we did is we're using gossiping property file snitch. We are configuring, we basically have one main key space that we use for KillrVideo that has all our tables. We've set that with a network topology strategy of replication factor of 3 per data center. So it's pretty vanilla, straightforward in that sense, nothing fancy. We have some scripting that we're using to, when we deploy the nodes, or I should say, when we deploy our cluster, to automatically, through scripting, disable that default admin user and create a new administrative user and give that the correct permissions, which is, again, these are things that you would do for any cluster that you were deploying. We've also, we've set up node-to-node encryption so that's there out of the box. And then for the client-to-node encryption, we've also configured all of our clients so they're also using SSL. So our services, when they're talking to our cluster, they are also using encrypted connections. So that's important because of some of the things that we did down at the networking layer, which was for our initial setup, we have not created any private networks between cloud networks or between the cloud providers at this point. We're just using public IPs, but we're encrypting all of the communication over there. And this is not something that's like live and running all the time right now. So don't, it's not like you can go out there and hack it right now. It's not. It's an experiment that we kind of spin up and down as needed. So obviously that's not a production solution. One of the other aspects that you want to think about is where are you routing things? If the entry point to your application is kind of your web tier, okay, so are you going to put like a global load balancer? Are you going to use a third-party load balancer maybe in front of that? Or what about DNS naming? These are some solutions that you're going to have to kind of pick out for your own application. So that's where we're at with respect to some of these security and networking aspects. there's a broader roadmap for the KillrVideo application. So it's a mature application. It does, we think, a pretty credible job of demonstrating, first of all, how to design a Cassandra data model, and then how to use the drivers to develop an application. It also does a pretty good job of demonstrating DSC search and that integration. We've done a bunch of things with DSC search to kind of extend the Cassandra query language with additional syntax so that you can use, for example, like the like keyword. I knew I was going to do that. Use the like keyword, and for full text search kinds of capabilities and that sort of thing. Some of the stuff that it doesn't quite do as well yet is demonstrate the analytics part of DataStax Enterprise. So we're definitely working toward having that. We have an advocate that just joined the team, Amanda, who has done a lot. She has a big analytics background, so we're going to have her help work on building out that part of the app, especially. And some of the other things that we're doing in general, I mentioned the idea of kind of replacing that etcd for service discovery and putting in a kind of a more fully featured service mesh so that we can begin to integrate some things like distributed tracing, for example, and looking to definitely use Kubernetes for scaling and scheduling the application layer. There's a few other things that we're looking to do. We're going to try to get a little bit more of like a customer 360 kind of aspect built into this application. And as part of that, we'll be doing some integration with streaming technologies like Kafka. And then we have we do have a number of things that, because this isn't like a real world product and a real company, we've been able to get away with doing a lot of things by hand. And we need to do a lot more automation, a lot more build and deployment automation. So that's coming as well. And I mentioned I'd love to have a Python implementation. So all of this work that we're doing to take KillrVideo multi-cloud is kind of part of our broader roadmap, and some of the things are more interdependent, especially like that service level infrastructure that we're doing. So just want to kind of summarize basically what we think we've learned so far from the effort that we've undertaken. Definitely think that using Kubernetes is a best practice at the application layer. The verdict is still out, both within our team and within kind of DataStax as a whole. There's an ongoing conversation about Kubernetes and its utility for kind of managing your database tier. So we know that we're hearing a lot in industry about it. We hear from customers that they're interested in that kind of thing. So this is definitely an area that we're exploring. We do think that there is a best practice in terms of trying to push, if you can kind of push this level of interaction down to the lowest layer possible, such that you're not storing state in your application, but you're letting your database be the repository for that state information. In other words, your Cassandra or DSC cluster. And we happen to think, of course, that we would, that this technology of Cassandra is uniquely poised. We all know, if you're a part of this community, you know that it's really unique in how it replicates and scales, and that it's not beholden to a particular cloud provider, which is one of the things that really made it attractive to begin with. So obviously, we recommend it and think that it's uniquely positioned as a multi-cloud database technology. And then, I'll just reiterate that last point that I made on the previous slide about automate all the things. So yeah, we know that we definitely spend time, even as a advocate team that is only coding on average, 25 to 30% of our time in a given week is probably spent coding versus doing a bunch of other things. So even for us, it might be especially important that we learn to automate as much as possible. If you want to learn a little bit more, I've just scratched the surface on this. We have our weekly podcast, The Distributed Data Show. So we did a whole 6-episode series. It was originally conceived of as like it was kind of funny actually. It was like a one-off, and then it was going to be a 3-episode series. And then by the time we got done talking about it, it was like a 6-episode epic. So hero's journey from episodes 56 to 61. We had a lot of fun with it. We hope that you find it useful, and we're always interested in having more people on the show. So if you have interesting use cases to talk about, whether or not it's open source or it's DataStax Enterprise, we don't care. We want to talk about these things. We're interested in it. So the more guests that we get from as broad a spectrum as possible, that's going to be better, and really make it a great resource for the community, that's what we want, and that's why we're doing it. So my final thing, because I want to pause and give you guys time to ask some questions, and we'll tell you the things that we know and the things that we don't know, and I'll bring Adrian up into the conversation for that. There's a bunch of people that helped us out in building up all this stuff, a bunch of content from Adrian. David, one of the other advocates, has been doing a bunch of this stuff as well as Cedric. Justin Brees, one of our SEs, has put together a bunch of awesome multi-cloud demos and spun up a bunch of clusters and took pictures of it for me. I appreciated that. Patrick for the use of his image, of course, in this presentation. Amanda, who's pictured over here on the right, for her support and review of all of this. And oh yeah, Hannah also put together the meme, so we'll credit her. Awesome community manager. So anyway, there's a lot that goes on behind the scenes to put even the simplest thing together, whether it be a demo or a talk or a video. And so anyway, we appreciate all our friends that help us out. So I'm sure I went too fast and glossed over something and made it sound easy, even though it wasn't. So where did I do that? Ask me your questions. Yeah.
Sorry. Yeah. I know it's not supposed to, but if did you find any disadvantages of communication in the case where you had the three cloud providers being used among the supervisors? Let's say, for instance, imagine that you had one scenario where you had two data centers from Amazon, and another scenario where you had one data center from Amazon and one from GCP or Azure.
Yeah.
And roughly at the same distance. I don't know if you did that in this case. Did you find any disadvantage of using a different cloud provider?
Well, so assuming that you have the networking configured, that's the big if, right? So that we haven't done like a side-by-side test to compare the performance and like resilience of those two side by side. So that's a case that I would like to have us test out.
It's also real tricky because if you deploy it out, it also is entirely dependent on.
Come talk into the mic.
In the mic. Oh, so comfortable.
I don't know if it's live. Try it.
I'll find out real soon. It is.
Oh, awesome.
So one of the things that's a big question mark is like what region that you've deployed your multi-cloud deployment out to, right? So like if you're in AWS East 1 and West 2, and then you're in GCP something else, and then in Azure Central US, each of those data centers have different dated or really modern or really old hardware and stuff like that, right? So if we did a test against, say, stuff deployed out to East 1 and AWS versus Azure's, like, I don't know if Central 1 is or what their newest thing is, but like their newest data center versus like AWS's old data center, the stuff ends up being completely different in performance. But then if we shift it all, let's say we get everything over to GCP West 1 and AWS West 2, that's basically, they're literally side by side, almost across the street from each other in manufacture and date of starting to use the data centers in the DAOs for those regions. So when you compare those two, you get a little bit closer examples for how they're using their hardware. But it's really tough to do completely straight apples to apples comparison of the deployments. And then of course, when you go past the app too, it gets a little different depending on what you're using in the cloud, if there is any specific stuff. So that was just, when you mention that, it's a really, really tough thing. And no matter what you really test, one versus the other, you end up with a little bit of apples versus oranges of a comparison. So you never really get one-on-one. You always kind of have to test per use case. That's what I would say.
Good.
So I was going to ask, you said you're moving toward an approach where you're using some VPC or something instead of public IPs. So, you know, I guess most of the stuff I've seen working with customers that had a hybrid cloud setup, they'd say, hey, we're going to put these services and these databases in the cloud, and then we're going to have some services on-prem like DNS or, you know, LDAP or something like that. And so, you know, I'm curious to know, you know, I think you get 3 cloud providers and you set up VPC between all 3 of them, and then you also have to set up a VPC from all 3 of them back to on-prem, so you kind of get this like graph of, you know, is that kind of how you see that working, or would you say, okay, we're gonna have LDAP only in GCP or something? That doesn't seem like that works.
No, I feel like this is the point at which I put the I am not a medical doctor. Yeah. These statements have not been evaluated by the FDA. I'm not a network engineer, so everything that follows is speculative. Okay, go.
My first thought is turtles all the way down, right? Yeah, the minute you start stepping into that with like the LDAP server, and what are you going to run in a provider versus all the providers versus whatever? Like how is your architecture going to run? It can get really messy really quick.
It sounds like you start to get this exponential curve.
Right.
Yeah, and the more resiliency you want and the more capability across those clouds, I mean, you have to get your services in each of those. Like if you just have your database, okay, you just have your database across the clouds. But if you only have your app in AWS, but you have your database across X number of them, but your app goes down, there isn't a lot of point in having your database across all 3. So you really have to think full spectrum, like your app, your database, your middle tier stuff, your peripheral services like your LDAP or whatever. Like how are you gonna get that across there? Is it gonna federate appropriately, or is it gonna fall down if one of them disappears? You know, that's like one of the big questions in Kubernetes world right now. It's like, all right, we have, you know, 10 different ways to run Kubernetes stuff in GCP. We have a billion different ways in AWS. Da, da, da. Are you running a full Kubernetes cluster in each environment, or are you just like you have your on-prem one, and then you're using their little specific services or something in Azure or whatever it is. So you really have to think full stack and girth-wise too. You got to cover all the bases.
Good. Well, I think we are coming up on time here. It's 1:50. So please come by. The DataStax table, we'll be hanging out. Either hanging out, talking, or recording some videos for pretty much the rest of the afternoon, the rest of the event. So come say hello, ask us the hard questions, and thank you very much for coming.